All right, we're looking a little bit more specific at isosceles and equilateral triangles. So first thing about isosceles triangles, just some terminology that I believe we spoke to before, but just being a little bit more specific about it here. A leg of an isosceles triangle is one of the two congruent sides of the triangle. In this diagram, AB and AC would be the legs. The vertex angle of the isosceles triangle would be angle A. It's formed by the legs of our isosceles triangle. The base of an isosceles triangle is the side opposite the vertex angle. The base would be one of the sides that are not the legs, not those congruent sides. The base of this triangle would be BC. A base angle of an isosceles triangle is one of the two angles of the base that are opposite the legs. In this case, B and C would be the base angles. The isosceles triangle theorem says if a triangle is isosceles, then its base angles are also going to be congruent. I think this is one of those things that we have noticed already. If a triangle is isosceles, then those base angles will be congruent. The angles opposite those congruent sides are congruent. And if a triangle is equilateral, it'll also be equiangular. We've also noticed this already, but here it is an official fact. Here it is as a reminder to us, something that we've already kind of discovered. If a triangle is equilateral, it's also equiangular. Here we have the converse. If two angles of a triangle are congruent, then the sides opposite those angles are also congruent. If we know we have two angles congruent, we know the sides opposite each of those angles are also congruent. That's saying that if we have two angles congruent, that triangle is going to be isosceles. And opposite what we had said earlier, if a triangle is equiangular, it's going to be also equilateral. Here, triangle DEF is isosceles. I'm going to draw that out. It says the vertex angle is angle E, so that means the other two angles are congruent since it's isosceles. The triangle looks like this. D is 36, that means F is 36, and that would mean that, those are both in degrees, and that would mean that E would be 108 degrees. The perimeter of GHJ is 12 inches. They say that G and H are congruent. If GH is 5 inches and the perimeter is 12 inches, we want to find GJ. Well, if the perimeter, if this is base angles are congruent, we know it's isosceles, so that means that whatever this side length is, this side is the same thing. So 5 plus 2 x's gives us 12. We subtract 5 over, divide by 2. Each of those side lengths would have to be 3.5. They want to know GJ. GJ would have to be 3.5 inches, because that is our units. Triangle is equiangular. Equiangular, here we go. And has a perimeter of 22.5 centimeters. Well, if it's equiangular, we know it's also equilateral. If the perimeter is 22.5 centimeters, we can divide that evenly by 3. Each side would have to be 7.5 centimeters. Each side, 7.5 centimeters. Two more theorems for us. If a line bisects the vertex angle of an isosceles triangle, if it bisects the vertex angle, then it is going to be a perpendicular bisector to the base. That means it is going to be at a right angle to the base. It's going to split it into two equal parts. Similarly, if a line is a perpendicular bisector to the base of an isosceles triangle, it's going to bisect the vertex angle. So here we have a statement and its converse is also true. That means the biconditional is true. If a line bisects the, a line bisects the vertex angle of an isosceles triangle if and only if it's a perpendicular bisector. These things go hand in hand. So let's think about these situations here. It says, explain why the base angles PAQ and PRQ are congruent. We'll take a look at the, here we go, PAQ and PRQ. We're looking at this triangle. Well, notice we have this segment right down the middle. That is congruent right there. That is by the reflexive property. PQ is congruent to itself. Reflexive property. It's secured by 4 cables of equal length. So we know that BP and PD, PA and PR, they're all the same length. So we know all of those are congruent because they have the same length. That's essentially what's given to us. I should have said that first. Over here I'm looking at PA is congruent to PR. That is given to us. And so now we have enough information to say these triangles are congruent right here. Triangle PAQ is congruent to triangle PRQ. That is by the hypotenuse leg congruence theorem. And so now we can say that angle A is actually congruent to angle R, and that's by CP CTC. So we know that those angles are indeed congruent.